Hello, beautiful people, and welcome to Teaching Sylvanas Math. This is our website. If you have a moment, go ahead and take a look. All you have to do is type in Teaching Sylvanas Math here on top, which will bring you to our homepage. You have an option to go directly to YouTube. You have an option of meeting Sylvanas. And then here we have our 3 classes for the 2020 school year. If you would like to meet Sylvanas, I highly recommend that you do. She is adorable. So if you click Meet Sylvanas, we'll take you to Sylvanas' Instagram page. And then you can absolutely follow her on Instagram. You are not required at all, but I mean, come on, she is adorable. We do have some videos there if you'd like to watch her play. Let's go back to our home page here. And then since this is an Integrated Math 3 video, we're going to head over there for Integrated Math 3. And then on the Integrated Math 3 page, you're going to notice all of the wonderful videos that have been posted here for you to review. It is separated into semester 1 and semester 2. So go ahead and head over there and take a look at what has been prepared for you. Now let's go ahead and get started with today's video. Now today we're going to be working with compound interest. Let me move this out of our way and shift the paper a little bit. So these are the formulas that you're going to need for your compound interest. The 2 interests that we're going to be focusing on is, one of them is going to be your K times per year. For example, it's going to happen twice per year. It's going to happen quarterly. It's going to happen semi-annually. So you need to know those key terms, like for instance, quarterly and semi-annually. You need to know what that means. So how many times per year quarterly means, what semi-annually, what does that mean? So that's one of them, K times per year. The other type of compound interest we're going to be working with is continuous interest. So continuous interest has our E in there. Now, E is not a variable, okay? It is not a variable. It does represent something. It is an irrational number, so think of it as pi. It will continue forever and ever. Now, E does not equal pi. So if you want to know exactly what E equals, you can go to your calculator and type in E to the first power, and it's going to give you the first few numbers of E. My recommendation when you are using E is use as many digits of E as your calculator allows. So just do E to the first power, or you can delete the exponent part of that. So for example, on my calculator, I'm doing E to the first power, which gives me 2.718, and then etc., etc., etc. So if you don't want to do E to the first power when you are working with continuous interest, all you can do is just do E and then go back and delete that and just do E, and it will give you the same thing. Okay, definition time. A is your amount after t years, basically your final number for both the K number of times and for your continuous interest. T is always in years, so 1 year, 2 year, 3 years. P is your principal or your initial starting value. R is your annual interest rate. And N is the number of times compounded. So N is what we were talking about, for example, semi-annually. So how many times is it actually being compounded? Is it being compounded 1 time per year? Is it being compounded 3 times a year? Is it being compounded 10 times per year? One thing I do want to mention is the interest rate, the annual interest rate. You need to convert that to a decimal. They will most likely give you your interest rate in a percentage. Like you'll hear credit card companies are going to say with a 2.8 interest rate. Yeah, so we need to make sure that we convert that to a decimal. All right. Make sure you have these written down somewhere or you have them memorized. For right now, for these examples, we are going to be solving using both. Okay. Let's go ahead and get started. Disclaimer. If I make a mistake, I am human. Just let me know where the mistake occurs so that way I can fix the mistake and that way we both can learn from my mistakes. I am recording from my home, So if you hear a loud noise, that is Sylvana's playing. She is running around. So if you hear something scurrying in the background, that is my kitty cat. All right, let's go ahead and get started. Michaela invests $6,113 in a retirement account with a fixed annual interest rate of 7% compounded 12 times per year. What will be the account balance after 13 years? Okay, let's translate this. I have my trusty marker. I'm going to be underlining, highlighting, things like that. Michaela invests 6,113. So that's her starting amount. That's going to be her P. In a retirement amount with a fixed annual interest rate. That is important because it tells you that it is not a continuous, and it also tells her that it's not a flexible interest, meaning her interest rate will not change. It started out at 7%, and in 20 years, it will still be at 7%. It is fixed. So we know that her interest rate is 7%. That's going to be her rate. And I'm going to convert that to a decimal right away. So how do we convert decimals? Here's your percentage. You're going to put a decimal point after the number, and you're going to shift it twice to the left. So I have 0.07. What you're doing here is you're multiplying by, you're dividing by 100. So it would be 7 divided by 100. So if you look that into your calculator, 7 divided by 100 should give you 0.07. Okay. So how many times is it compounded per year? It is compounded 12 times per year. So that is our N. There's kind of no room to write that, but I'm going to write our N. What will be the account balance? So what is her final total? So we want to know the final amount, or our A, after 13 years. So 13 is our T. So again, let's go back to our formulas. Which one do we choose? Now, initially when we did our quiz, I noticed that a lot of times we are struggling to which formula to use. If it does not say continuously compounded, keyword, if it does not tell you that it is continuously compounded, it is your K times per year formula, okay? Compounded K times per year. So let's write this out. So Michaela invests, I have my formula sheet not too far away from me. So I'm going to say we want to know the final balance. Michaela invests $6,113 times 1 plus R, which is 0.07, divided by 13, divided by 12 times per year. And then it's raised to 12 times 13 as the exponent. Now you will need your calculator for this, okay? Get out your calculator. So on my calculator, I am doing the parentheses first, then I'm doing the exponents, okay? Remember PEMDAS. Parentheses, exponents, multiplication, division. So inside my parentheses, I have 1 plus 0.07 divided by 12. So since addition is commutative, I'm going to say 0.07 divided by 12. And it doesn't matter if it's not pretty. Just don't worry about it. So I have 0.07 divided by 12 plus 1. Now all of that raised to the 12 times 13 power. And then I'm going to multiply that by my initial value, by my principal. And I get this value here, 15,146 And then you have to read the question. So what are we talking about? In this case, we're talking about money. How do we typically round money? Money is typically rounded to 2 decimal places. So I have 564, so I'm going to round it to 56. Make sure you put the dollar sign so it makes sense. So what will the account balance be after 13 years? So if she invests $6,000 with a 7% fixed annual interest rate that is compounded 12 times per year or monthly, they could have said monthly, and she lets that sit for 13 years, she will have $15,146.56. All right, let's go ahead. I'm going to skip number 2. It's very similar to number 1. If you want to try that on your own, you have my blessing. Go ahead. Let's try number 3. Eduardo invests. So again, highlight, underline, notate. So Eduardo invests $2,373 in a retirement account with a fixed annual interest rate. So again, fixed annual interest rate of 2%. So we know that's going to be our RR. Get it? RR sound like a pirate. Okay, so convert that to a decimal. Some mistakes happen when you don't actually do 2 jumps to the left, but sometimes you only do 1. So just take that millisecond to actually do that. And it's compounded. Ooh, hold on. Red alert. Compounded continuously. I see a key word. That is your key word. Whenever you see that, compounded continuously, continuously, you know you're going to be using this formula here. Okay, what will the account balance be after 13 years? It's going to be our T. Okay, continuously, continuous. Keyword means you have to use the E formula. The way you can think about it is E is continuous, it is irrational, so it's continuous, it goes on forever. So if you see continuous, that means you're using E, which is also continuous, if that helps you out. All right, so let's write out our formula. Our formula is A equals P times E to the RT power. So A is equal to, he invests $2,373 times E. Remember, E is not a variable. Okay, it's an irrational number. E, and then that is being raised to the R times T power. Okay, so how do we type that into our calculator? Again, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Okay, so we just care about the beginning part. That's usually the confusing part. So I know you can't see it because my calculator is darker in color, but let's type this in. I'm going to say E, so E to the 0. Well, actually, I'm going to back up a little bit and I'm going to put parentheses. 0.02 times 13 power. I'm going to press enter. Again, it doesn't have to look pretty right now. And then I'm going to multiply that by 2,373. So we have $3,000.60. Again, so how do we deal with, you can't see what I'm writing, but how do we deal with decimals and rounding? You have to look at what is given. So in this case, we're dealing with money. How do we round money? We round money to 2 decimal places. So then I have 615, 5 or above, you get round up. So I have 62. There we go. So A is equal to $3,077.62. Right? Number 4 is similar to number 3. You have my blessing to go ahead and do that. Let me switch that over so you can see what it says. All right, number 5. Michaela's famous. She gets 2 questions on this worksheet. All right, Michaela invests $3,621 in a retirement account with a fixed annual interest rate of 3% compounded continuously. How long will it take for the account balance to reach $6,402.89? Okay, again, Michaela invests that much money. That is our initial amount. In a retirement with a fixed annual interest rate, again, fixed annual interest rate just means that the interest rate will never change. Okay, so interest rate is 3%. That is our R value. Again, convert that to a decimal. Take that extra 2 seconds, 1 second to make sure that you're jumping 2 decimal places over, not just 1. Okay, again, keyword, compounded continuously, keyword. How long, okay, now we're dealing with something different. How long, meaning T. We don't know the time, we want to know the time. So how long will it take for the account balance to reach? So we know what the final is. We know what the initial is, we know what the principal is, we know what the final amount is, we know what the rate is, and we know that it's compounded continuously. So what we don't know is the time. So how long will the account, if it is compounded continuously, get to $6,000, a little over $6,000? All right, so let's see here. Again, continuously, meaning you use the continuous interest formula. So I have A is equal to P times E to the RT power. So I know what A is. I know what my final product is. My final is $6,402.89. I know what my initial is. My initial is 3,621. E is not a variable. My rate is 0.03. And my T is unknown. Okay. Step number 1 here is to get this bubble on its own, okay? E is the base, and then T is in the exponent, and those two are attached. The only way that we can undo it is with a property or a definition. So these are all kind of glued, super glued together, and we can't unglue them, we can't undo it unless we have a definition or a property. So what we can do here, though, is we have 3,621 divided by, just kidding, is multiplied. So we're going to divide both sides by that number. If I haven't mentioned that you need a calculator for this, I'm going to mention that right now. You need a calculator for this. So 6402.98 divided by 3,621. I get, let me see if I have enough room. I get 1.7682-ish. Now, I'm not going to round. Yes, I am writing this here, but in my calculator, I'm leaving it. Okay, I'm not writing anything. I'm not using what I'm writing. But just in case something gets deleted, I have it down here, and that would be a 3. Okay, now I have my e to the 0.03 power times t. Okay, this is where a lot of you get confused. Oh, and I accidentally deleted it, so let me do that. Okay, this is where you guys get confused. This goes back to our rewriting